Welcome all of you. A galvanometer of resistance 100 ohm shows a full scale deflection for the current 10 to the power minus 3 ampere or 1 milliampere. To convert it into an ammeter of range 1 ampere, we have to connect a resistance. Option A 1 ohm in parallel, option B 10 to the power minus 3 ohm in parallel, option C 10 to the power 5 ohm in series, and option D 100 ohm in parallel. So at first we need to understand that galvanometer, okay, which is basically shows the deflection, it basically shows the direction of flow of the current. Its resistance is 100 ohm, so its resistance is somehow we can say the medium value of resistances, because the ammeter's resistance is very low. In case of ideal ammeter, resistance is 0. The resistance of the voltmeter is very high. In case of ideal, resistance can be infinite or the large value. But here we have to convert this galvanometer into an ammeter. Okay, so we have to basically make a instrument whose resistance is very low, very small. Okay, so how to do it? We can do it by connecting some resistance in parallel with it, because we know that if we connect two resistances in parallel combination, okay, so its equivalent is less than that of the least value of the resistances. So from this knowing, from this understanding, we can directly say that option C and option D, option C is cannot be the answer, okay, and option D, option B and option A can be the answer, okay. So if we just think of it, then we also need to think that if we connect a resistance in parallel with it to make it the minimum value, to make it this minimum value, okay, of combination of G and S, the value of S should be minimum, okay, then the equivalent of G and S will be less than that of S, okay. So my prediction is the answer is option B, because this is the minimum value of resistance and it is connected in parallel. So let us check it out, I am correct or not. So the maximum value of current that can be passed through it is Ig. So Ig is equal to 10 to the power minus 3 ampere or 1 milliampere. So if I want to convert it into an ammeter of resistance, range 1 ampere, then we can say capital I, that is 1 ampere is entering from here, okay. So obviously 10 to the power minus 3 ampere or 1 milliampere passes through it, and rest of the current is passing through this S resistance, that is the shunt resistance. So what is the value of the current passing through it, the shunt resistance? That is I minus Ig, that is the rest of the current, okay. Here we have to find out the value of S. So if we simply just use the Ohm's law, and if we just mark this node as A and just saying that potential of A is VA and the potential of B is VB. So according to Ohm's law, we can write down simply VA minus VB equal to Ig into capital G, Ig into capital G, that is the potential drop across the galvanometer should be equal to the potential drop across this shunt resistance, because both are connected in parallel combination, okay. So if I now use the data, that is Ig equal to 10 to the power of minus 3, the resistance of the galvanometer is given 100, the value of I is 1 ampere, so it is 1, and it is 10 to the power minus 3, 10 to the power minus 3 into capital S. So if we have done this, try to understand this. It is 10 to the power minus 3 here. I am just doing a simplification. Okay. So if I just write it down as 1000 into 10 to the power minus 3, then I think you have no problem. Then I can take 10 to the power minus 3 as a common. Simple mathematical technique. So if I take this common, it becomes 1000 minus 1 into s, so it becomes 999. Okay. So if it is, then just see 10 to the power minus 3 and 10 to the power minus 3 will be cancels out, and s will be equal to 100 divided by 100 minus 1, that is 999. Okay, ohm. So if I try to calculate it, if I try to approximate it, okay, so this value of resistance is very close to, we can say 1 ohm, very close to. Okay, so the option A is correct from this calculation. Hundred by 999. So I can, if I consider, I can approximate this 100 divided by 999 as 100 divided by 1000, approximation. Okay. So this approximations gives us, these zeros cancels out, so it will be approximately 1 by 10 ohm, or we can say 10 to the power minus 1 ohm. So 10 to the power minus 3 is far behind this, so option B, what I have predicted, it is not correct. It is slightly greater than that of it. So 1 ohm in parallel, that is the correct option. Exactly, you have not obtained the correct value. Okay, 10 to the power minus 1 is not here, so we have to take which is the closest one. Okay, 10 to the power minus 3 is far behind than 10 to the power minus 1, but 1 ohm is close to it, that's why I have taken this option A. Thank you all of you. V equal to Ig into R plus G. So V is basically